So the question we are going to do today is 3 sum. It is the 12th question of our NeetCode playlist and 15th question of LeetCode. So we have already done 2 sum question before in the 3rd video and in the 11th video. If you know how to solve that one, then this one is very easy. So now let's see what this question says. In this question we are given an array which can have positive or negative elements. Let's take this array for example. 4, minus 2, minus 1, 0, 3, minus 3, 1 and minus 4. Okay. So the array can have 0 plus positive element, negative element. So now the question says we have to give all triplets. All triplets means the pair of 3 elements such that their sum equal to 0. So let's say for example 4 and 3 minus 4 minus 4 0. The sum is 0. And let's say minus 2 minus 1 plus 3 equal to 0. Let's say minus 3 and plus 3 and 0. And 1 minus 1 plus 0 and minus 2 3 minus 2 minus 1 plus 3. Did we do it before? 1 plus 3 minus 4. So you get the idea. Okay, any the sum of 3 numbers such that the sum is 0, we have to tell all the pairs. So how to do this? First we will do the brute force obviously, in which we will generate every possible pair. So we want 3 numbers. Okay, A plus B plus C. If we fix A, if we know that A is this for sure, then we just have to, this was the equation we want. Now we know A is 4. So if we send this to here, so we got B plus C equal to minus 4. Now if we can just do 2 sum problem so that we get the sum minus 4, then we pair that 2 numbers with this one, so we get the 3 sum equal to 0. So we have fixed this one, this is A. Now for the rest of the array, we try to do the 2 sum problem. As usual, we will have 3 approaches. We will use the best one. Okay, so the best one is, we will just do full brute force. So now we have fixed 2. Now we want B and C out of this. So again we do the same. We fix B and then we loop and we find if we can find a good C value that can give the sum as 0. If not, then what we will do is we will move B. B is this, let's say. So we have A and B. Now we find a C which is valid here. Not this one, here. 4 minus 1 minus 3 equal to 0. But if we can, we still keep going. And even if we did, we still keep going because we need all the answers. We fix this B, then we check all C. Then we fix this B, then we check all C. B, C, C, B, C. Now we have checked every possibility for this A. Now it's done. So now A is here. Again B, C, 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 B, C, 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 B, C, 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 same process. Then again A comes here and then B, C, 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 same loop. So basically 3 loops. So it is O of n cube. We will do one I loop, then one J loop, then one K loop. This will the first element every possibility, second element every possibility, and third element every possibility. And each time we get ith element plus jth element plus kth element equal to 0, we will save that. Okay. So this is done. This was our O n cube time and O of 1 space because we did not use any extra space. So now same as 2 sum problem, we will try to optimize it by removing the time, because time is taking too much. So the first logic we did, that fix one element, that will stay the same for all methods, because this is not 2 sum, this is 3 sum. So we need to at least do some brute force, because it can be, basically it cannot be done in single of loop. The max we can go is O of n square, and right now we had O of n cube. So we will try to go to that. We cannot reach this state in any possible manner. So we have fixed A. Okay, but now problem is just 2 sum in this array. So as we did earlier, why we do O of n square just to get together 2 sum when we can do it in O of n. So we will make a set, hash set, and each time we see an element we will store it. Minus 2 is seen, and now we will see first time we loop all elements. Okay, we store the elements in set. Minus 1, 0, 3, minus 3, 1, minus 4. Or we can just do it while looping also. Each time we get an element, we ask if its pair is already in a set or not. If it is, then we add it as an answer. If not, then we don't. So you can see the video. I will add the link. So this will be O of n time and O of n space only for 2 sum. And we have to check the third element for each element. So obviously there will be one more O n. So it will be O of n square and O of n space. Time is good enough. It cannot go beyond better than that. But we are still using some space. But if we can do it in constant space. So let's try it. In the same loop, what we will do is, in 2 sum we have seen the optimal method is to sort the array and then use 2-pointer approach. So we will do the same here also. We will sort this array. So what we get out of sorting is minus 4, minus 3, minus 4, minus 3, minus 2, minus 1, 0, and then 4, 3, 1. 1, 3, 4. So we have sorted the array right now. Again, as I said before, the first element fix, this will say constant. We have to do one loop at least in the full array, and then the second loop. So A is fixed. Now for this, we have to find two sum such that we get the sum equal to 4 of two elements, so that when we add it to this, so we get 0. So now simply we will just, as the array sorted, so we will make a pointer here and make a pointer here, and we will keep going until we can find a target. And even if we do find target, we will just keep going anyway. So now this is 1 and we want 4. So the sum is smaller, so we go beyond this. Now the sum is 2, but we want 4 because 4 minus 4 equal to 0. Minus what we have, we want a 4. So now sum is 2, still we go even higher. Now sum is 3, we go even higher. Now sum is 4. So we got the first pair, which was minus 4, 0 and 4. But we still keep going. What if we find a better answer? Now we go here, we got 5, but we want 4. So that means we have to go smaller. Now we are at here, we got 3 plus 1 equal to 4, which was the one we wanted. So again, another pair will be minus 4, 1, 3. This is done. Now in the next case, we will make the A as this one, and then we will do two sum here. So this will give us O of n square, 1 O n for the outer loop and 1 O n for the two sum problem, and O of 1 space, as we did not use any extra space. So this was the most optimal solution for this question. Thanks for watching, and I will see you in the next video.